Alright, so this is the second lab we would have done in class had we actually had class. This is your monthly payments or monthly investments. Once again, the problems are on Moodle. The blank one is there, followed by the answer sheet. If you haven't done so, go ahead and pause the video, get the problems, work them out on your own, and then come back and go ahead and we'll go through them and correct them. All right, so number one, if I deposit $200 a month into an account that gets 3.5% interest for 40 years, how much would I have at the end of the 40 years if I'm looking to retire? So payments, that would be 200, brackets with the parenthesis, 1 plus 0.135 divided by 12 raised to the 12 times 40. Then subtract the 1 and then 0.135 divided by 12 for the denominator. Once again, it is possible to plug everything into the calculator and solve it. However, if you miss one parenthesis or one little mistake, you get the whole thing wrong. So I would recommend numerator first, then the denominator, keep them separate. So if I plug the numerator in, I would get 213.831. For the denominator, it's 0.01125. So I multiply the two numbers in the top, divide by the denominator, and your $200 a month for 40 years has turned into $3,801,437.08. So if that was your retirement, very nice job. I'm pretty sure you can retire on $3.8 million. All right, number two. If you invest $400 a month at 13.5% for 20 years, how much would you have at the end? So 400 parentheses brackets 1 plus 0.135 divided by 12 times 20, and then subtract the 1 divided by the 0.01125, and you would end up with $485,586.09. Notice between number one and number two, you put the same amount of money in. Okay, for number one, you did $200 a month for 40 years. For number two, you did $400 a month for 20 years, so half the time. So even though you put the same amount in of your money, you ended up with almost $3.3 million difference in interest. Okay, so when you're doing these, hopefully you remember from the lectures, the two big things that dictate this is the interest rate and time. Okay, so when we did housing, we talked about the different interest rates would influence how much you could afford. Okay, this one we're talking about time. If you're saving for retirement, earlier is better. That's the difference between 3.8 million and 484,000. Big difference. All right. Number three. We have a credit card. Credit card, 27% interest, $4,100. We want to pay it off in 3 years. What's a monthly payment? So we're going to pull up our monthly payment formula. So the payment equals the principal times the interest rate divided by n over 1 minus parentheses 1 plus the interest rate divided by n raised to the negative n times years. So 4,100 times 0.27 divided by 12 over 1 minus parentheses 1 plus 0.27 divided by 12 to the negative 12 times 3. Once again, you can plug everything in at your own risk. I would do them separate. And 92.25 divided by 0.551 means you would make monthly payments of $167.38. All right, so when you pay it off, how much have you paid? Well, you're going to pay once a month for 3 years, so that's 36 payments. So $167.38 times 36 is $6,025.68. That is what you would have paid off on a $4,100 credit card bill. So just under $2,000 in interest. All right, so the last one, we did college funds with a one-time payment. Okay. Most of us don't have that type of money. So we're going to do a monthly payment. I want $100,000 in a college fund in 20 years. If my APR is 11%, how much do I need to deposit per month? So in this case, we're looking for the payment. So 100,000 equals the payment times 1 plus 0.11 divided by 12 raised to the 12 times 20 minus 1 all over 0.11 divided by 12. So the numerator would become 7.935. The denominator is 0.0091. That gives us 865.638. And when I divide that into 100,000, I would make monthly payments of $115.51. Okay, which is fairly reasonable for 20 years to have $100,000 in a college fund at the end of that. All right, similar problem. Let's say you got 10 years instead of 20. Okay, so the only thing that's going to change is instead of y being 20, y is now 10. And that means our numerator becomes 1.981. When we divide that by 0.0092, we get 216.998. And if we divide that into 100,000, you would have to put $460.83 into the account. Okay, so once again, interest is important, so is time. So 20 years, you put $115 in a month. If you want 10 years, you've got to put $460 in a month. That's more than doubled, like it's almost triple what you'd have to put in every single month. Simply because you're not letting time help you in doing your interest. All right, number 6. I have a 15-year, $130,000 home loan at 4.5% interest. What are my monthly payments? So principal, $130,000. Interest rate, 0.045 divided by 12. And for the denominator, 1 minus parentheses 1 plus 0.045 divided by 12 to the negative 12 times 15. The numerator is $487.50. The denominator is 0.4902. And your monthly payment would be $994.49. All right, number 7. If I have a $45,000 student loan, 6% interest, and I'm going to pay it off in 20 years, what are my monthly payments? So back to our payment formula. 45,000 times 0.06 divided by 12. Denominator is 1 minus 1 plus 0.06 divided by 12 times negative 12 times 20. And we get 225 divided by 0.698. And our monthly payment would then be $322.39 every month for 20 years. So if I take that and I times it by 12 and I times it by 20, that would be month in years, you would end up paying $77,373.60 to pay back your $45,000 student loan. All right, I have $14,000 on a credit card. I'm getting an APR of 27%. I want to pay it off in 3 years. So 14,000 times 0.27 divided by 12. and then 1 minus 1 plus 0.27 divided by 12 times, or raised to the negative 12 times 3. Plug in just the numerator, we get 315. If you remember, that is your interest for the first month. Divided by 0.5511 means you would pay $571.55. So out of that, $315 is interest, and the $256 would go to principal. And then it changes after that for the first month, but that tells you what you're doing for the first month. All right, so how much do we end up paying back? So 571.55 times 12 for months times 3 for years means we would pay $20,575.80 back on a $14,000 loan. All right, number 9, I'm getting a $175,000 mortgage. I'm going to get a 15-year loan at 3.2%. So 175,000 times 0.032 divided by 12. 1 minus parentheses 1 plus 0.032 divided by 12 to the negative 12 times 15. So $466.667 divided by 0.381 means I would have a monthly payment of $1,225.42. So that would be my payment every month. Times that by 12, times it by 15, and you would end up paying $220,575.60 for your house. Now, if you decided to go with the second option, we can get a 30-year loan at 4.5%. So 175,000 times 0.045 divided by 12. 1 minus 1 plus 0.045 divided by 12 times raised to the negative 12 times 30. And we end up with 656.25 divided by 0.740, and we would have monthly payments of $886.70. So $400, $350 less. However, if I take that $886.70 and times it by 12 and times it by 30 for month and years, you would end up paying $319,212 for your house. Okay, so while it does save you money each month, it's going to save you almost it's going to cost you almost $100,000 more over the life of the loan to pay off. So if you can pay a little bit more on your mortgage or student loans or credit cards or whatever you're paying off on, it does kind of hurt a little bit in the meantime, but in the long run, it does save you, in this case, $100,000 and 15 years off the life of your loan.